hier und schauen hierher. Erde warten, bis ich verbrenn. Der Himmel brennt, die Engel fliehen und ich ersticke in schwarzen Wolken. Mein Fehler war, ich hab geglaubt, du wirst mir ins Feuer folgen. Doch der Himmel, den wir wollten, der Himmel brennt. Ich liebe dich, ich schreie die Worte an die Wand vor mir. Dort hängt dein Bild, ich drehe es um, ich will es nicht mehr her. Auf dein Wohl, du weißt doch, dass ich dich glaub. Warum lässt du mich hier in laschem Traum? Freunde, der Himmel brennt, die Engel fliehen und ich ersticke in schwarze Wolken. Mein Fehler war, ich hab geglaubt, du wirst mir ins Feuer folgen. Doch der Himmel, den wir wollten, der
ACDC. Yep. Yeah. Yeah.
Der Himmel brennt, die Engel fliehen, wir sind durch Rauch und Feuer getrennt. Der Himmel brennt, die Engel fliehen und auch uns weit waren vertrieben von all dem, was wichtig war. Bis jetzt am Ende nichts geblieben von der Hoffnung und der Liebe.
This was sent in last class, so.
Die Engel fliehen und ich ersticke in schwarzen Wolken. Mein Fehler war, ich hab geglaubt, du
It's now a German music channel.
mir folgen. Doch der Himmel, den wir wollten, der Himmel brennt.
What weird stuff is in my follow-up? Doodle power metal. Should probably talk about UML, maybe. Alright, how are we all doing today? Alright, so I don't know if any of you noticed, so after class on Monday, I updated the midterm stuff in the term project. So on the 28th, we have these teams going, and then on the 30th, we have these teams going. So just be aware that 28th and 30th will be Blackboard Collaborate days. I'll send out another announcement just to remind everybody when we get closer to that. But again, I'll be expecting your teams to chat. And make sure we've got pretty much everybody here. Got some people here, at least. Streamlabs is always a good solid 5 minutes behind what Twitch actually shows me, so there's a good chance that if you're coming in late, you're gonna have to watch this at the rewatch the beginning here. But just be aware of what day that you're going. And again, max 10 minutes per team. So I'm going to assume that you're all okay with this. I haven't heard any complaints as of yet. I'm sure the complaints will come later after everything's all said and done. That's when complaints normally come in. Alrighty. Let's do some UMLing. Oh, look at that. Nifty emote. I don't know that I want to know. One of my former students at OU turned me into the the brawny man, the paper towel lumberjack guy, had one of those red and black checkered shirts, and I think I was in deer hunting / winter preparation / hockey playoff mode, so it's a bit fuzzy. That became a Discord thing for a while. That was fun. Alrighty. So we ended about here, right? We were talking about the different UML relationship types. Right? We have boop, boop, boop. We have dependencies, generalizations, associations, aggregation, composition, and that's pretty much where we left off, right? So if you don't remember anything from Monday, just a quick summary here. UML is a language. It has a particular syntax, meaning the structure of the diagram means something. It also has semantics, meaning that there are basically intents and meanings to the words behind, like what's going on. Syntax is like the construct of it. Semantics is the intent or the meaning. If you've ever looked into how English works or how any language works, you get those similar terms. But the point is that these models have something behind them, and knowing what different line types mean what is kind of important here, if you're going to use UML. So filled diamond, composition, empty diamond, aggregation, distinction between both, just depends on who owns the objects, right? If we remember from last time. We have the numbers with the asterisks on our diagram. These are your multiplicities. These words can mean roles. They can have like association meanings. It just kind of depends on what the word is, right? Obviously, these are going to be your classes. You may have more information, right? You might have things like attributes or methods or on here. So that's just kind of to recap where we are at. And again, I don't expect you all to be experts just by listening to a day and a half of UML chat. You'll get more practice on this, and it will hopefully become a bit more clear what you should be using when. So then we have some relationships to wrap up here, and then we'll talk about the class diagram proper, because I've just been kind of using them to illustrate these points. So we have realizations as well. And this looks like a generalization, right? It's got the white triangle at the end. Difference is the line is dashed, okay? And what this basically means is that we have something called an interface. And this is just effectively a way to access something in a way. Think of like an interface where you have to go past the interface to get into the actual data, for instance. For a realization, this is specifying something called a contract, which we're not really going to be getting into too much in this class. Basically, these are things that have to be done in order for the class to carry out its operations. And to give you a little bit of an example here, this is one form. So there's actually two forms of realization. I'll show you when we talk about class diagrams. This is called the canonical form. This is canonical form, basically. So here we have a class. It's realized by this particular interface. Interface tends to start with an I. So like here we have account business rules. So what are the business rules we have for our accounts in our company, right? So what are the rules behind things? And realize I'm using the word rules and assuming that means something, but we could have an interface here that handles these actions. So do we have to add a new rule? Do we have to change a rule? Do we delete a rule? Maybe we have to explain why some particular action was taken for a rule. Again, a rule is kind of just a nebulous concept right now. It's just something that has to be followed, right? It is a actual rule. But this realization here means that we have an interface that is specifying how these business rules are to be handled. Right, and I realize we haven't really talked about interfaces yet, but keep in mind realizations generally work with interfaces. And I thought I had, sorry, feel like I'm going crazy because I added... Oh, this was what I added. Okay. I thought that I had added and then removed something by accident right before class, but this is actually what I added. Because if you look at the PDFs in Blackboard, this slide doesn't exist. Basically, I just said, here's realization, understand it. But I think I accidentally deleted that. Live slide updating in class. The best content on the internet. All right, back to reality here. So we've got realization. That's one of our other relationships, right? Looks like generalization, but the line is dashed. Typically, you're going to have an interface associated with that. Okay, so those are basically all of the relationships that we're going to talk about. I've contextualized them in terms of class diagrams, but I haven't really said what they are, right? So this would be an example of a class diagram. And again, I know that most of you probably saw it in your Intro to Java class. My afternoon class, there are some students that actually never saw it, so I'm guessing sometimes the classes are taught differently. So my bad on assuming you knew what these are. You know, if you're sitting there quietly, not understanding what the heck I'm talking about, that's my fault. So here we have a class diagram, and this is a fairly complicated one, complicated-ish, right? Each of these boxes is a class. So assuming you're coming from Java, everything is class and package based, right? So this would be a class, this would be a class, this would be a class. Each class will have attributes. So these are going to be your public, private, protected methods. Attributes. These are your variables, right? So it's this first box here are going to be your attributes. Typically, they have what the name of the field is and what type it is. So is it a string? Is it an integer? Is it a name? Well, what's a name? Well, we probably have a name class somewhere else that would point to this thing, but it's not in this context of the class diagram. It should be, though, if we're referencing it. So we have our attributes here. None of these have any of the extra designators, but you would also put if it's public or private or protected, right? Going with your data hiding principles that you should have gotten from the Intro to Java class. You would reference those with like slightly different notations. Here, we're just assuming everything's public, so we don't have to add any designators. Underneath, we have our methods, or operations. So what are the functions that this class can do? Right, so a person can get a photo, get a soundbite, get contact information, get personnel records. I almost said personnel records. But these are the uncommon operations. These are not your gets or your sets or your instantiates or your destroys, right? Those are assumed to be there, basically. So you don't typically put the common things. And if you don't have any operations, you just leave that field off. Again, these are all kind of assumed to be public by not having any designators there. So the purpose of the class diagram is kind of twofold. So we're showing off all of the classes in our system, which if you look at this diagram here, and again, this is person to department to company to contact information to personnel record. This is obviously a business-related class diagram, like specifying probably an ERP type of system, like it's entity or employer resource, but basically it's how you track all your people, where they're sitting, what their payroll is, all of the company-based stuff at the back end. That and more. It's a huge field. But we're trying to show how each object is structured and who it's related to. Right, so a person, for instance, here is related to a department. A person may have contact information. A person has a personnel record. The department is related to people. The department is related to an office. These are both related to a company. So all of these classes are related to each other. And by specifying the correct UML relationship, you can basically demonstrate how your code should link these classes up. Right, so for instance here, this is again the generalization object, right? So solid line with a triangle. We have an office. We have a specialized instance of an office called headquarters, right? So headquarters will have an address. It will have a phone number. Headquarters may have other special attributes as well. They're not shown here because maybe we don't have any. but it could be like we could have a field, is this the global headquarters? Is this the North America headquarters? Is this, Eastern Europe headquarters, right? So basically this inherits everything from Office and it would specify extra things. Okay, that looks great as a picture, but what does that mean for your code? Well, what this would mean is that I create a class called Office, and then I inherit from, I create a subclass called Headquarters that inherits everything from Office. Similarly, well, not similarly, I guess in a similar fashion, we also have a department, we have an office, right? These are two logical entities. A company will be composed of these classes, right? So we'll have one or more departments, we'll have one or more offices. The company object will be responsible for instantiating and destroying departments, right? Because it's a hard physical realization or association here. It is a composition. Whereas if we had an aggregation, which would be the empty diamond, these would be different, right? So you can hopefully kind of see how these relationships all play. And then we have the little designators on, excuse me, go away. No, not all the way away. We have the designators on the relationships, right? So we have multiplicities here. Come back, pointer, please. Thank you. So we have one or more departments in a company. We have one or more offices in a company. A department will have one or more people as a part of it, but there will only be one manager. We may have self-compositions here. So a department may be composed of other departments. So you might have like a sub-department. Think of if this was a school environment where you have the School of Computing and Information Science, but you have a Department of Computer Science, a Department of Computer Information Systems, whatever you have. Basically, you can do self-associations here. All right, other thing that's slightly different in this model from what you've seen already. There is this little dangling circle here. So this is an interface. This is basically your realization from the last slide. So it is effectively this, except this is called Lollipop Notation. It's a little more simplistic to try and make things a little more readable in a way. Basically, a personnel record has an interface called I secure information. Basically, if I want to access somebody's personnel record, I need to go through this interface. Oh no, my face is covering it. Thank you. I am the interface to your slides. Terrible professor joke. There we go. All right, lollipop notation, not professor face notation. But it's a little circle. It's just an interface. What's an interface again? Come back, please. Basically, it's a class that's designated as an interface. You are welcome. I apologize for that. I should probably watch that a little more closely. So yeah, basically we have all of the, the majority of the relationships on this slide here. Other things we have, so roles, so member, manager, right? So a person can be a manager, a person can be a member. A department and an office will have a location that are tied together. They may not strictly be attributes in one of the classes. However, this may be specified somewhere else, or it may be part of that semantic intent where you're trying to give more clarity to other people reading the diagram. It just kind of depends how you want to realize this thing. Right? So I've got some animations popping in here that makes the slide a lot busier. Let's see, what else do we have that I didn't talk about? Oh, constraints. So this is one thing which we can also define in basically any kind of diagram in UML, but a constraint basically means this particular thing has to be met for this other thing to occur. So in this case, a constraint in this fashion would be a subset, and I mentioned last time, constraints are typically in like curly braces here. A subset of the members of our department will be a manager, if this kind of makes sense. So we are putting a constraint that a person that works in our department is a manager because we have this dependency here. we could also have a constraint that, you know, a office must have at least one department or something of that nature. All right, so hopefully that makes sense. And again, you don't have the full syntax of the models with what you're seeing here. Waffling on if I make you all do class diagrams or not for your next assignment. You probably will have to because it's a good skill to have. But basically, I would give you the rules for how to make a class diagram. You know, if I were to ask you to go ahead and do that, and I assume everybody could, right? All of you are more than likely doing something object-oriented, and if not, it's pretty easy to coerce it into this format. Oh, that was the other thing too I should mention before I go too far, is what we're talking about after we're done with UML is design patterns. So when you start doing class diagrams like you see here, you can start applying design patterns early on. And this can make your job a whole heck of a lot easier if you can capture what you want at this level. And the reason why I say that is that a design pattern, generally there's a reason you would use a design pattern. For instance, there's the singleton pattern where you can only ever have one instance of this thing. You can represent it very nicely in a class diagram or a facade or an observer or visitor pattern. So all of these patterns, which we're going to talk about, they're very easy to represent graphically. They're tricky to implement. So if you start going really way down the rabbit hole of designing your program and you've written code, well, then all of a sudden, hey, I need this particular pattern to expose an interface or to secure information or just clean things up. You're going to have to go through a massive code refactoring process to coerce everything to use it. Whereas here, you just say, oh, this is a singleton. Everybody is related to this singleton, for instance. Just kind of one of those little niceties that if you capture things at a higher level, it actually makes your job a lot easier later on. Alrighty, so I'm not covering anything, I think. Good. So a few questions for you, and honestly, these are, you know, some of these are more or less common sense slash self-explanatory, but can't always assume that that's the case. When do you think you would use a class diagram? So let's say that your company wants you to use UML, right? So you have to do a diagram. At what point in the process would you use it? Is a question to you all. I don't have a slide for this, just, you know, pop it into chat here. So as you work on your responses, keep in mind class diagrams are structural, right? We have implementation details kind of in there. We're starting to specify patterns for implementation. So when would you use this type of activity? He said, sneakily finding time to drink coffee. Near the beginning of the project. Could be. Could be. Any other guesses? I'm just going to keep doing this. And coming together after different people have worked on different parts of the project to try and communicate what everyone did. Also a good guess. So basically, we have two kind of viewpoints here, right? So at the very beginning, or after everybody has worked, and then you're trying to kind of come together after defining requirements. Hey, look at that. We've got 3 different guesses. Wonderful. Wonderful. Thank you. Let me say yes to all of those. So let's start with John Garrison's point. Near the beginning of the project, you can do class diagrams very early on, but they're going to be very sparse, and you're probably not going to have a lot of implementation details. So let's pop back here. Right there. So this might be a really good example of an early, yes, we all win. Points for everybody. You like a little popper to go. Here we have a very simplistic class diagram. There are no attributes in here, there are no operations in here, but we have a feeling for which classes we're going to need and how they may be related to each other. So this could be an early one. We're going to refine these models as we go, right? Would you do a class diagram usually at the beginning of the project? You would probably wait a little bit. So probably after requirements have been defined and you actually know what you have to be doing. But there's nothing stopping you from doing it early on if you have an idea of the project. All right, so if you have requirements, then you can get a little bit deeper, right? You can start doing things like this. Well, if I have a company, what's a company going to be made of? Well, it's going to be department, office, so on and so forth, right? And our requirements are going to specify that you have to track people. People have to have personnel records. Those personnel records have to track their salary and their tax ID and their social security and blah, 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 right? So depending on which phase of the process you're in, you will get more detail here and you will refine this model. And then to the point in the middle from RK231, it's more fun reading people's anonymous names than your actual names at times. That's kind of funny. Watch when you all go for graduation, I start introducing you as your Twitch handle. But after coming together, so you've all done some work separately, now you're trying to integrate your projects together. You can use this as well as a way to communicate. So absolutely, that's definitely a good point too. Hey, here's all of my code. Here's the class diagram associated with it. Now let's try and add relationships to what you did, possibly. Or maybe you've all worked on various subsets of this diagram and you're all, on the same page because you have a unifying class diagram to show you what's going on. So honestly, there's not a bad time to use class diagrams. I honestly think they're very helpful, right? Because they give you an idea of structure, they give you an idea of relationships, and that's 50 to 60% of what you need for a project. All the other diagrams have more or less different levels of importance, but you're kind of getting a feel for hopefully how you can take a project and break it down into manageable chunks. So this is the structural side. Obviously, it's more useful for coding, whereas the use cases are more important for requirements, elicitation, and all that. So the second question here, would the type of process change? And the answer is no, not really. So if you're doing a waterfall model or an agile model, you're doing Scrum or Kanban or extreme programming or whatever agile process you use versus prototyping, if you want to use a class diagram, that's not going to impact your software process. Right, and now we know, and it's not just my cynicism bleeding through, but Agile does use slightly different words and sometimes different model types, right? Like Waterfall used Gantt charts, Agile uses burn down, burn up charts. You can still use UML in Agile and have a successful project. So your actual process does not have to change. This will apply anywhere. And if you remember back to the very beginning, this can even apply to non-software projects too. It's domain independent. All right, last but not least, so this is another open question for you all. Let's say that we have a code base, right? So I've written a whole bunch of Java code, which you probably will never hear me say, personal bias. But if you have Java code and it's in something like IntelliJ or Eclipse or any of the big IDEs, there are generally plugins for automatically generating class diagrams from that code. Can you think of any pros and cons for automatic generation? And I guess depending on your perspective, you can answer it class diagram to code or code to class diagram. You would probably get very similar answers. But are there any pros and cons to this kind of activity, automated generation? Speed. So that would be a pro. We can speed things up. I could see that. That's definitely a valid answer. It's going to save me some time and effort, right? If I need a class diagram, and I've written a whole bunch of code, I just click generate class diagram, click, and then I get hopefully a class diagram that represents what I did. Are there any cons to this? I will say if you have never worked with an automated generation tool before, you may not know the cons, so don't feel bad if you're reaching for answers. So I will say when I was in industry, and this is starting to sound like back when I was your age, I should, shave my beard so all the white goes away and I look like an undergrad again. But when you automatically generate things, more often than not, there's going to be lots of chunks missing or incorrect translations that appear. So if you have an automated code generation tool, for instance, you're not necessarily going to get functionality. You're going to get function stubs, or you're going to get things just like blanks filled in. You're not going to get the whole thing working, more than likely. And if you go the other way, you may have class diagrams that get automatically generated, and it's wonderful, but they become super complicated, right? Everything in your code base is modeled in there. You get very busy class diagrams, possibly lots of overlapping lines and interactions that you didn't realize existed, which could be a good thing, right? If you have unintended interactions, that's a good thing. But the key is that you have to have a very well-defined model or a very well-written code base for automated tools to work. So you get speed, which is great, but you also have the downsides of automated, which is it's going to just spit out what you put into it, basically. So it could be good and could be bad. All right, so this is the, not Slido, it's the Unsplash representation of object. It was the least offensive one I could find in there. So now we're going to go to object diagrams. They are highly related to class diagrams. What an object diagram shows you is basically an instantiation of a class. So let me pop through all of these things here so that you can read it as I talk. Basically, take a class diagram, take the relationships in that class diagram, and fill in the blanks with an actual object. So if you have let me go back here one more time. If we have this class diagram, an object diagram would say Grand Valley State University, School of Computing and Information Sciences, MAK, whatever the office number is and phone number is. Person would be Eric Fredericks. Employee ID would be my Grand Valley student faculty ID card value. Photo would be whatever's in banner, right? So an object diagram takes what you've done here and actually creates something from that. Now, why would you think that's important? What's useful? Obviously, you're maybe going through the motions of creating a real world object, but what does this show you, for instance? Probably should have made this a slide, but this would basically be you writing in code, okay, here's my school manager program. I'm going to instantiate every single object, right? So like I'm reading from a database, here's all my people, here's all my departments, and I'm creating these class objects. The object diagram you do by hand or, in one of these tools, and you do it for like one or a subset of the objects. What's the benefit of doing this activity to you? Today is Ask Students Questions Day because I need more caffeine in my body. He said unironically. It'll show you what additional requirements you may need to add. Absolutely. So let's take an example here. So here we have, and this is again one of those standard class diagram UML learning examples. I have a class called dog. I've specified everything I need to know about a dog. The object diagram instantiates this thing. right? So here's its properties, here's its methods, here's what we fill in for this dog, right? Once we fill it in, you may realize that you're missing something. Or you may realize that there is an operation that doesn't exist that should. So you need to fix your class diagram to add more or remove something. Or if you go further, you can relate this to, say, an animal superclass or an owner, or basically anything you need in this particular class diagram. You can instantiate it at a point in time. That shows you what's right, what's wrong. Basically, it's going to show you what happens when you sit down and code this thing, what the internal program's going to see. So to your point there, yeah, it might show you initial requirements you need, or maybe you're missing use cases, or your requirements need to be refined. It comes down to you're getting more information here. And this can be a very helpful exercise for basically checking your models, right? Did your class diagram work? Yes or no? Well, if you have a problem with your class diagram, we made our class diagram based on our use case diagram, based on our communications diagram, based on our requirements. Again, they're all linked together. And if you have those links like specified, then you can see exactly what's wrong in every single location. All right, so here we have a dog again. So sit, lay down, shake, and come, right? So these methods are all available to our little yellow. I say it's not a lab. His ears are too pointy. This be this looks like a shepherd or a husky kind of a thing. You wouldn't really have a yellow. Maybe it's a Shiba. There we go. It's a yellow one. So is that everything that a dog can do? Well, no, right? It's an animal. It's got a million things it can do. Are these the only attributes a dog has? No, right? Maybe it's three-legged. Maybe its eyes are different colors. So you can basically go down the list of what you've instantiated here, and maybe this is okay for your program, right? You're doing something very high level, who cares? But the point is that it shows you what you're missing. Where am I going here? Okay. So let's take this class diagram example, and probably should have removed all the arrows and stuff so that it's less busy. If I wanted to instantiate this thing, and again, this is going to show you require relationships here. Here I'm going to go ahead and actually add values. So you don't necessarily need to show the methods because those are going to be there anyway, right? But I've got basically some IDs here. So C : company is what we've got. D1, D2, D3. So we're going to have these objects designators. Excuse me. We're going to fill in the attributes that are specific and basically show how everything's related in here. And what else can we do with this object diagram? Well, you could take it and see if your, for instance, multiplicities make sense, right? So here we've got one person in our department. That person is a manager. Technically, we fulfill our requirements of one manager, at least one person. That manager is a person. Right, so we have everything that we need in here. So it's a refinement activity, basically. It's a model checking in a way. So I actually had another example for you as well. For my grad class, I started doing my little game. Oops, I don't want that. I want this. So basically, I started creating a use case. This would be that state machine that I was talking about last class. Basically, what are the different states of your thing? And then I started working on my own class diagram here because I thought it'd be useful to show. So I've got a game class, I've got an overworld class, I've got towns, I've got entities, and I've got various basically components for this, or entities that are based off of this general entity. So this would be my class diagram, right? And I built this based on code that I already specified. So for instance, everything in my little code base here, and just because I always have fun with what I'm working on. So I've added a bunch of stuff to my game. Well, I actually added this all to my class diagram. So now I've got towns, and you can't really see it here, but you've just entered New Ottery St. Mary. Or, let's see, usually they're down here for some reason. My random function isn't super great yet. But basically the point is that I've got, I need to hit escape because it doesn't like the close button, so I forgot to add that in. But basically I've specified all of these class information in the game, and now I've translated it to my class diagram. I've refined things as I've gone. So if I wanted to instantiate it, well, here's everything I need for a town. It's got a name, it's got a location. Here's everything I need for an entity or for a player character, a non-player character. Oh, question. All right. So is it beneficial to place the boxes in a specific order? It depends on your intent. So my suggestion to you would be to place your boxes so that it is most readable, if that makes sense, because class diagrams can get really busy. In my example here, the entirety of my game is centered around this entity component system. So basically, this is the design pattern I've applied to pretty much every object. So it kind of takes front and center view. Your biggest goal with like a class diagram, object diagram, is to make lines not overlap, because you can get super busy class diagrams. Let's see if I can find a good one here. Yeah, here we go. Get something that looks kind of like this. Yeah, it's transparent. That's helpful. But even these you can kind of read because nothing's super overlapping. I guess it's really hard to see the blue in here. But just make it readable would be my suggestion. But anyway, with the model that I was just showing you, I'm not trying to show what I've been working on too much, more so that like there's a whole lot of stuff missing and incorrect in this model that I created intentionally because I want my grad students to find the problems with it. But if I start instantiating objects, I will see exactly what's wrong. Like in my class diagram, towns had names, but they didn't have locations. Well, how do I know where they are in the map when I go to code this thing? So with, oops, scrolling to, stop scrolling. Thank you. So with these object diagrams, when do you use them? The answer is going to be after you've created your class diagrams. Can be, again, whenever you are working on class diagrams. Usually it's a good activity for fact-checking yourself. Again, checking your models, which reflects into your requirements. And again, one change at any point in your project will have basically implications at every other stage. It might be a tiny one where it's not a big deal, but like if I find a problem here in my object diagram, right? So my department needs more than just a name. Okay, well, that means I need another attribute or another method or something, right? Okay, fine. Well, this was specified based on my use case diagram, which was specified based on requirements 5 through 20. Requirements 5 through 20 have test cases associated with them that make sure they're being, checked, that the behavior of the program is being checked appropriately. Well, if I add another attribute, I might need another use case. I might need more requirements. Those requirements are going to need test cases. So again, it's all linked together. And it doesn't have to be as big of a deal as I'm making it out to be. It's just something to be aware of for all of you. All right, so it's going to be the same answer with object diagrams and the process. Doesn't matter what process, doesn't matter what domain, you should use them. But an interesting question, how many object diagrams do you have to create? Right, so here there is one. Here there is one. Do we only need one object diagram? And the answer would probably be no, or it could be yes. It just depends, which is an unfortunate cop-out in a way. Basically, you need enough object diagrams to demonstrate the functionality of your class diagram. So if I have a generic case, like this, and that's all my system's ever going to have, this might be enough. But if I have like a bunch of edge cases where, okay, I've got a company, I've got a bunch of departments, and oh, by the way, this one is out in Antarctica, it has a bunch of special fields and operations associated with it, then I probably need to specify that as well. Basically, you need enough object diagrams to kind of exercise your model. And when I say exercise your model, that basically means you're just putting it through its paces. You're making sure that everything works for all of your kind of boundary cases, your edge cases. Just make sure that you're covering everything. So hopefully that makes sense. So class diagrams, hopefully we're good on at this point. And again, I'll give you the formal syntax when you need it for the various models that I would expect. Basically, I've got some reference material with like, this box means this line means this, and it's from the grad class textbook, so I'll just add that to Blackboard in the near future. But again, it's a structural diagram. Hopefully we can see the benefit of it. Now we're going to go on to the behavioral diagrams. So class diagram, object diagram, those are the structural. Again, kind of implementation focused. Now we're going to go into the behavioral. This is the dynamic side of things. This is the data flow side of things. Ordering. We're not looking at all of them. We're going to look at basically the sequence diagram and the communications diagram. Semantically, they basically show the same thing. They just give you a different perspective. So let's start with sequence diagram. This is basically going to give you a ordering in time of message passing. And what is a message? Basically, a message is going to be like a function invocation. I'm calling the function in this class at this point in time. These are going to look a little bit interesting. Basically, every object is going to have a lifeline. Every object is going to have an execution window, or it's called a focus of control here. Basically, this box that we're going to add onto a dashed line shows when something is happening. So let me show you an example here. Here is an example art auction. So this is a sequence diagram. So here you have your actors or your classes on the top. Everything is read from the top left down. So basically all you have to do is start at the top left and follow the arrows. So I borrowed this figure from Professor DeVries, so I get to make fun of him for his choice in diagrams here. I've got a different one that I pulled from another set of my materials that I like better. But Osbert here wants to buy some art. So basically we have a person, we have a user interface, we have a class, and a bunch of classes. So each of these things have meaning. So this circle with this little line here, this is basically a boundary. We are bounding our system. So basically, in order to access this data, we would need to talk to an interface. That is basically all this means. Our control objects are basically going to control the interaction between our various classes. And then we may just have a straight up entity, where this would be a class object of some kind. You don't always need this level of detail, but this is more kind of giving you an example of all the different types of things you can have in here. More likely than not, these are just going to be little stick figures at the top here. But let's go through this diagram at a kind of a high level. So this is the focus of control, this little box, execution window or execution action. It's got multiple names. Basically, when things are happening to this particular actor, you have a box. That's all you really need to take from it. So step one, give masterpiece details. So I need information about this artwork. Okay. Well, I talk to this user interface class where I'm going to take the request and forward it on to this particular control entity. So I'm going to give masterpiece details. this is going to forward me on because this is an interface. It's going to transfer the details to this class. Well then, oh sorry, Osbert is the one creating the masterpiece in the system, not looking for information. Or maybe he is, I'm not sure. It kind of depends here. So we're instantiating things live. I was reading this wrong when I was going through the slides before. Sorry about that. So we're basically going to create a masterpiece class object in the system. So the notion is still the same. We're flowing along here. So we are going to get this object, and then we're going to see what else exists. And then we're going to get a price. We're going to display the price. And then it's possible that the offer on this artwork is rejected. The whole key here is how this diagram is structured. So the dashed lines are the lifelines. These are when this particular actor or object is alive in the system and participating. So basically, again, vertical is your kind of responsibility. Horizontal is the timeline. And again, follow the arrows there. If you see an X, that means something got destroyed. It doesn't exist anymore. So let's go to a slightly different example here. And if this notion of boundary doesn't make any sense, like I was talking about this user interface class, it's got a boundary. I've got a link here to read up a little bit more if you want to know. It's basically one of the design patterns out there. But the thing you're supposed to take away is that this is basically object communication and how that happens in time. This is a little bit more of a simplistic view. So here we are basically taking money out of a bank. Okay, so you have a customer class, you have an ATM class, and you have a server class. The designation here, if there's a colon, basically this is the class, and you would have a customer if it was an object. If you don't have that specified, it's just the class. Here, server would be basically some entity within the system because it's not strictly a class. Point is, you can have kind of different notations in here based on what you want to show. So to kind of wrap things up with sequence diagrams here. So again, lifeline makes sense. These are when the objects would participate over time. Little execution window / focus of control. That's when things are happening. And we follow the arrows. And usually on the arrows, you would put what operation is happening. So in this example, we have a customer. Again, we're starting at the top left. The customer wants to get some cash, so they put their card in the ATM. All right, so this is my operation. Customer has a put in card method. ATM then has the card inside of it. I am now alive. Check the card. And interestingly, this model kind of goes from English to German randomly, which is kind of interesting. So the ATM class has a function called check card, and it takes the card's date, basically, is it a valid card? And it will check, is the card okay? And if it's okay, it's going to pass on the user information to the server. The server then would return, basically, you would specify what the return value is. Typically here, we're just kind of saying okay, and we're kind of saying the rest of the interaction we don't care as much about. But we might get some validation information here. The ATM would then either give money or reject card, things of that nature. All right, so that little bleep in my ear, and hopefully, I wonder if it came in your ears too, but that tells me class is done. We'll talk a little bit more about sequence diagrams next time as well to kind of wrap it up, but we're trying to get some communication ideas across here. Again, we're getting behaviors. Anybody have any questions before I end the stream and go kick off office hours? If not, I will see you all Friday. And I should mention too, obviously, it's a crazy semester. If my office hours do not work for anybody, please feel free to email me and just see if we can figure out a time to chat. Because I'd rather, if you have an issue with homework or your project or anything, that we figure it out, before the end of the semester. So I'm more than willing to make appointments outside of office hours if anybody needs to talk about anything. I had one term project team talk to me yesterday, and we spent a lot of time figuring out technology. So again, more than happy to meet at any time. I should feel like I should specify that. Because I know when I was a student, I never wanted to go talk to my professor outside of their office hours because I felt bad. But don't feel bad about bugging me. It's okay. All right, otherwise, we'll see you all next time. Bright and early Friday morning. Have a wonderful day. And bye-bye for now. Let's end with Pikachu. Woo! You too. Actually, you know what? I quite enjoy dancing crabs. So there we go. Bye, everybody.